So what we're going to do today is talk about batteries, charging, and electronics, but not servos. We're going to talk primarily about batteries and how they work and how you can make them work better. A lot of new people have problems with batteries, and the main problem I think they have is that they, if they have what we call a wall wart, which is a battery charger that plugs into the wall, usually has two leads, they will not get in any trouble with that. And that's the reason why with our club boats we provide those. The wall wart charges at such a slow rate that you cannot destroy a battery pack. On the other hand, you've got to plug it in usually on Wednesday to sail on Saturday because it charges at such a slow rate. So what new people do is the first time they go get a decent battery charger, this is the one that we have recommended. This is called this is an MRC Superbrain 960, and this is about a $60, $50 battery. We have recommended battery chargers like this that have a variable rate charge for a long time. So what happens is somebody starts with a wall wart and everything goes along fine. Then they go get one of these and they jack it up to 3 amps because they want to charge fast. They go to the pond and the battery won't work. And we've had that happen just this year with some of the newer guys. So what we want to talk about is why that type of thing happens. We want to talk about batteries, what the various types are, and so forth. And we have a write-up, and the one we have, when you download it, will not be stained with coffee like this one. But there is a write-up called Electronics and Batteries, and this is on our website. You can download it. And this was originally written by Frankie Novak. And then since then, I have updated it. And it's updated for all the more recent developments in terms of batteries, because this is a changing technology, it changes all the time. The main reason it changes is because of model airplanes and because of cars, model cars. Because they're trying to get the longest possible run time and the fastest possible charge time. And those are mutually exclusive using standard rechargeable battery technology. So they're really pushing the envelopes. There's all kinds of different batteries that you can get. It's very confusing, and I'm going to try to simplify it a little bit. I'm going to talk about batteries to start with because the chargers really are dependent on the batteries that you're using. The basics of battery, any battery, whether it's a DC battery of the car type or a battery like we might use, all batteries are essentially operate under the same principles. And it doesn't matter really how they work internally, but it matters to us how you treat them. And so if you hit the measure of a battery is of course battery voltage, that's very important, and battery capacity, which is expressed in milliamps, that's 1,000th of an amp. A thousandth, right? 1,000th of an amp is a milliamp. So the capacity of a battery is like the capacity of your gas tank. 19-gallon gas tank, 1,500 milliamp battery. And a 1,500 milliamp battery is a 1.5 amp battery. So it will run like a fuel tank. It will run out at a rate of 1 amp. So if you had a boat that drew 500 milliamps through your servos and your receiver, drew 500 milliamps, and you had a 1,000 milliamp hour battery, theoretically at full charge it would run for 2 hours. Depending on the kind of battery you use, the characteristics of what would happen during that 2 hours would be different. And I'll talk about the types. But that's the basics. So when we recharge a battery, it's like we're filling the fuel tank in your car. Like the car, if you fill it too fast, it's going to, in the case of a battery, not run back out of the pipe and stain your shoes, but what it will do is destroy the battery. And so we'll talk about that too. So first we'll talk about types of batteries. Battery packs can be purchased at hobby stores, they can be bought online, and I have done all of that. I tend to buy a lot of online, but probably I'm about half and half. So I just bought 2 packs from the hobby shop in Geneva, and just bought 2 packs because he had the right kind of packs, and so I try to support him, and I needed a couple of them because every time I sell a boat I usually have a pack that goes with it. The other thing is I will discover packs that start to fail. You can pick up using some of these devices, you can pick up when a battery starts to fail. So the types of batteries is very confusing, so I'm going to try to deconfuse it a little bit. The batteries that we're all familiar with are, let's start with AA alkaline batteries, a Duracell. It's a dry cell battery. Those have a capacity somewhere between 1.5 milliamp hours, 1500, and about 2500. So when you buy for example, Duracell just came out with one called a Quantum. Okay, that's their most powerful battery. That battery is about 2400 milliamp hours. When you put those together, what they do is they put them in series when they wire them in a battery pack. So they solder or weld either silver plated or copper plated leads from terminal to terminal, and they alternate. If you ever replaced a battery in a device, usually you have to go positive this way, then positive the next way, like that. And what they're doing is they're chaining those together, where the positive terminal on one battery is connected with the negative on the next one. When you do that, each time you do that, you're doubling the voltage. Okay, so we'll talk about voltage and amperage. Amperage, as I mentioned, is capacity. Amperage draw is drawing down at that capacity. So voltage, on the other hand, is actually electrical pressure. That's the way I always described it, probably oversimplified, but it's electrical pressure. The more voltage you have, the more oomph you're going to get from your device, whatever it is. So for example, if you put a 4.8 volt pack in one of our boats, it's light, it'll have 4 cells probably, 4.8 volt, and you will sail around and everything will be fine, but it'll only go for a shorter period of time, only work for a shorter period of time. And also your servos will not have the same power, they will not develop the same torque as if you had a 6 volt or even a higher voltage. So the alkaline AA cell is the one that we will compare to. Everybody's familiar with that, the Duracell. When you have 4 or 5 Duracells chained together at 20, and they're all 2400 amp, you will only have a 2400 amp pack. It will be more volts because the Duracells are 1.5 volt output. So you would take 4 times 1.5, and that's how you get to your 6 volts. But there are still 2400 milliamp hour pack because each cell individually is 2400, and they will run down evenly. That's the reason why you would want something that, as close as possible, would match the cells. Because if one's 2400 and one's 1500, you really got a 1500 milliamp pack, because that one battery in there will downgrade the whole system. So when you buy better batteries, you typically get more matched packs. So if you buy a custom pack made by somebody who matches them, like Cheap Battery Packs does, that's an online source, you will get closer matched packs. And I'll talk about my experience with that type of pack versus the ones you just buy at a store. The second type is the old original rechargeable AA cell was a nickel cadmium, NiCad. And those were something that was used back in the 70s and 80s, and that was one that you can still buy those. Those have a one big negative, and that is that they have a memory. And that means that as you discharge the battery, when we sail, we use, let's say that you had a 1500 milliamp hour pack, that you used half of it each time you sailed. Within about 5 or 6 cycles, you would no longer have a 1500 milliamp pack, you'd have a 750, because the thing develops a memory. And in order to get that back, that whole performance back, you have to discharge it fully and then recharge it 1 or 2 times, and that will get you back to your original capacity. When I say discharge fully, I mean not 0, I mean down to about 1 volt. A fully discharged battery, you never want to take it below about 1 volt. So the second type, nickel metal hydrides, are not a good choice for sailing. They're really not a good choice. They're used somewhat right now they're used in telephones, because the telephone's always plugged in, always in its stand. And they'll use them in some other devices, but those are fading away pretty quickly. NiCads, yeah. The next type that was developed is a nickel metal hydride, and that's, they say, they express that as an NIMH, nickel metal hydride battery. It's different chemistry. That's the one that most of our people in sailing use, and it's starting to change a little bit, but that's still what I use. Nickel metal hydride is a rechargeable battery that does not have that memory effect. And they will not develop a memory. They're very, very reliable. They're very similar in performance to a NiCad in terms of charging and in terms of using them, but they don't have that memory effect. So those are a nice, that's the one that I would recommend to most new people because it doesn't have any of the negative characteristics of some of the others that I'll get into right now. More recently, they've developed a lithium polymer battery or a LiPo battery. Lithium polymer batteries were developed primarily for airplanes because they're they put out a lot of power for their weight, and they also put out higher voltage, so they have more oomph into your servos with a LiPo battery. They have one little downside, and that is they can burn your house down. LiPo batteries react very negatively to overcharging or charging too quickly. That's something a lot of new people do. That's one of the problems. In a LiPo battery, there have actually been, the owner of Hobbytown in Menor actually had a customer who burned his garage down. He charged LiPos, he went to Giant Eagle, and when he came back he had no garage. Everything, all of his airplanes, everything burned because they explode into flame when you overcharge them. Or if you charge them too fast. So there's two ways to make them blow up, both of which people do a lot, newer people do a lot of times. So that's why they actually sell bags that you're supposed to put the LiPo in order to charge them. So you're supposed to put them in this fireproof bag and close it up, start your charger. You're supposed to never leave them alone, which is a good practice for really any battery charging application. But when you have one that's as sensitive as a LiPo, you've got to watch them very, very carefully. The other negative is they don't like water, which makes them not as good in boats as they would be in airplanes. So a LiPo battery is one that I would absolutely never recommend for what we do for sailing. And there are people who disagree with me. When you go, like at our most recent regatta, you could go boat to boat to boat, and you would find people using LiPos because
is there a difference in weight between that?
Yes, well, they put out more power so that you can use a smaller one.
Oh, okay.
So therefore lighter weight.
Okay.
Now they're also very expensive. So a LiPo pack might be 2 times or even 3 times what a nickel metal hydride pack is. So a nickel metal hydride pack that we use is typically $20 to $25. You can get them for less, and you can also pay more. A LiPo would be $60 to $75, $80, and you have to have a different charger. So the normal charger would not work on a LiPo. There are chargers who will do LiPos, that will do LiPos or nickel metal hydrides or NiCads. That's one of them here, which I'll talk about in a minute. In fact, many of them. Any of them on this table will do that except this one. So LiPos are not a good choice. More recently, they've developed one called a Life battery, which is a lithium iron, I-R-O-N. I first learned about this from a guy from Southern Ohio, so I thought it was iron, lithium iron, but it isn't. It's lithium iron. So it's a Life battery, L-I-F-E battery.
Yeah, if you use iron.
Ferrous. Yeah, ferrous. So those are probably of a high-tech nature a better choice for sailing. And over time, probably the Life system will start to take over.
And they're lighter than LiPos.
They are light, they have a lot of capacity, and I have here a chart which shows the characteristics of these batteries. I'm not sure whether you can actually see this. I can pass it around, but essentially the nickel metal hydrides and the NiCads and the standard Duracell type dry cells have very similar patterns, and that is that the black line here is what a Duracell type battery does. It drops, it starts off at about the same voltage, but it very quickly begins to lose voltage. So your 1.5 volt battery, by the time it's been used about 20 or 30 minutes, is probably about a 1.1, 0.9 or something like that, and it's gradually declining in performance during its entire life, which means you're getting less radio range, you're getting less push on your servos, less torque. The higher lines here are the red and the blue line are the nickel metal hydride and the life or lipo battery, and that is that they also decline, but they do it on a much slower basis than would a dry cell battery. The top line is the lithium, the life battery. It holds its voltage way high during its entire life, and then it just falls off the table at the end. That's why a lot of people like it, is because it has full performance, pretty much its entire charge life, before it drops. So you have full radio, you have full power. The only negative on the life battery is that it's very unforgiving of a mechanical problem in the boat. If you get a sheet tangled, if you get for some reason something jams up, the servo's history. And they will actually, I mean, in seconds, blow it right out, because it's producing huge amperage all along its life, its charge life. So that's the only real negative. And if I were starting, knowing what I know now, and if I was starting out, I probably would start with the life system. But again, it's a different charger, different packs. You'd have to get rid of everything you had and start over with a whole new system. And there are people that have done that. A lot of people are starting to use the life batteries. So we would recommend those, or the nickel metal hydrides as being the two choices that we would recommend. Nickel metal hydrides are extremely forgiving and inexpensive, and the chargers are inexpensive, so, which is why we recommend those for new people.
And the duty cycles. Is there a life issue with the life, I mean, as far as
Rechargeable
memory,
cycles?
the memory thing?
No memory.
With the life one?
No memory. Now, the other thing about life batteries is that they have a very large number of cycles, and they're very reliable in that way, and I'll address each rechargeable type. The NiCads are very forgiving, will recharge thousands of times without any negative effect if you charge them properly and if you drain them properly. Nickel metal hydrides, for some reason, are sort of unreliable. So you may get a pack that you can recharge 200 times, and the next pack will do it 75 times. I have some that are 2 and 3 years old. They're still working like a champ. But I've also had some that charge 2 times, no more. And those I always send back. I return them. So that's the downside of nickel metal hydrides, but on the other hand, they are very inexpensive, they are very forgiving, and they take a relatively low cost charger. A life charger will be $80 to $100, whereas you can get a nickel metal hydride charger for as low as $25.
Does the guy out in Geneva carry those?
He has all of the types that I've just talked about.
Okay.
He has everything. Probably doesn't have NiCads, but he has everything
Right.
else. So you can look into all of those different types. So getting into chargers, I have a sampling here of some chargers, and the thing about a charger is you need to have variable rate. You need to be able to vary the rate, and the more expensive charger has an infinitely variable rate, whether that's an electronic device doing that, system doing that, or in this case, whether it's a knob that does it. The variable charge allows you to charge the battery at the proper rate, and that's expressed in C's, is the way the battery industry describes it. Now, 1 C is being charged at the rate of the capacity of the pack. So a 1500 milliamp battery pack charged at 1 C would be charged at 1.5. So it's the amount that the charger would apply in 1 hour. It would recharge the battery from 0 to full charge in 1 hour. That's a C, 1 C. And I'll express that because that varies, and you can do that. That's a fast charge. 1 C is a fast charge. So a 1500 milliamp hour battery, totally discharged down to 1 volt, you could charge in an hour and a half safely. You are, in effect, if you do that, you are hurting the life of the battery by doing that.
Charging it too fast.
1C, yeah, that's borderline. If you go over that, all bets are off. But the car guys, they want to charge in 15 minutes. So they have to use a much higher quality battery, and they zap them, you know, at a race, because an electric car race guy runs for 4 minutes. So they dump a 2,500 to 3,000 milliamp pack in 4 minutes. And then they want to recharge it in 15 minutes.
Fast electric boat.
Yes, and it's, yeah, same thing with boats. And so that's very, very hard on the batteries. It takes very high quality batteries. So an electric car racing guy, it is as much as anything, as much as your skill, it has to do with whether you have bought and can afford the best batteries. And they match the batteries exactly. They'll put 5 exactly matched cells in a pack, and they're very high quality cells. Sanyo is one brand. That's a very, very high quality battery. We don't need that in sailing. So let's talk about some numbers for sailboats. I actually have measured this, and I'll show you how with this. My sailboat uses about 300 milliamps per hour. So that says that I could sail 5 hours on a charge of a 1,500 milliamp battery. It also says that if I buy 2,500 milliamp batteries, I'm really wasting money, because I will never sail that long. That's 10 hours or something. It just won't happen. So as a result, I typically buy 1,500 to 1,600 milliamp packs, because there's no reason to have any more. When I go home, I put it on my charger, and it tells me how many volts are left. And the charger at home will say, after we sail a full 2.5 hour session, regardless of how windy it is, light it is, and I will be still, I start at about 7.4 volts in the pack, and it will not be below 6 when I get home.
6,
Yeah, 6.1, 6.2. I draw relatively low. I have digital servos too, which typically draw more.
That's what I thought, yeah.
But I draw very, very low because the system, meaning the sail arm, the friction and all that, has been eliminated as much as possible. That's the reason you might put blocks on your sail arm, is to lessen the friction. So you increase the efficiency, and you also don't wear your sheets out as much. But even with all of that said, and 1,500 milliamps, if you treat it right, will do everything you need to do. You don't have to spend any more money. I know we have guys in our club that have 2,500 milliamps packs, and the only downside is that it just takes more money. You know, they just cost a lot more money. There's the difference between the 1,600 was like $17.99, I think, at Toy and Hobby, and a 2,500, one of the green packs, the Hobbyco packs, will be 25 or 26 bucks. And you can get even more.
You're basing your power draw on what your battery shows you when you get back to the house.
Well, yeah, plus I also have calculated it using a discharge charging device, this is one that I owned for a while and sold to Tom. I have another one that's digital. This is digital readout, but this is a less sophisticated unit, but also this is the AccuCycle, Hobbyco AccuCycle. You could buy the new AccuCycle, it's about $150, which will do everything but sing Dixie. I mean, it does everything you can imagine for 10 packs. It records all the details. You punch in a pack number, you hook it up, and it will record how many it took. Everything about it. And that's the ultimate, in my mind, the ultimate charger would be that AccuCycle, the new version. This is an older version, which was designed around NICAD technology. So it's just an older pack. I bought this and sold it to Tom for about half what I paid for it, but I'd used it for 3 years and used it very successfully, and that still works great, I guess. So onward to yes.
Oh, okay.
Onward to chargers. So this super brain would be, and there's a different one that I have in the write-up, and what I base this on is price, features, and availability. So this one we're currently recommending is let me look here, is a Profit Plus by Dyno Charger, and that was available and widely available in hobby shops. It's a nice charger, and there you can get those for $30 or less. but it is not a discharge charger. It's only a charger. So the variables on it are whether it works, and this is to me a very important thing, is that I have to have a charger that works on AC and DC. I have to have something that can plug into the wall and something I can use in the car. So in the basement, I have one of these. This is the first charger I ever got because Frankie Novak recommended it. This is a quick field charger Mark II. They also made a Mark I, which was around NiCad technology. I would not recommend getting that because it has a time limit on it that makes it impossible to charge at the rate we need to charge. But this Mark II is about $50. I converted it by taking the alligator clips off and putting on a lighter plug. And this will do 2 batteries. It has 2 sets of outputs. It is a DC only charger. This does not have an AC. So I have a power supply that I plug this in at home on the shelf so that I can use this. But then I have 2 of these. I have one that I keep in the car because this plugs right into my auxiliary outlet. I charge my boat on the way this morning. I charge the Soling that I brought, the Soling 50. And it will charge variable up to, it goes from 0.2 to 2.0 amps. Okay, so this would charge any of the batteries that you're going to use at a 1C rate.
Is that variable?
It's variable by turning the knob, infinitely variable. I always use this at about 0.4, 0.5. So I'm charging a 1500 milliamp hour pack at 400. At 0.4 would be 400. I can do 2 at once. So I can do a backup, 2 sets of leads, I can do the boat, and I can do a backup. You should always, another thing that's a little bit, I won't say controversial, but people disagree on is whether or not you should use a switch in your boat. Because if you use a switch in the boat, it's going to probably have a charging lead, which makes it so much more convenient than plugging and unplugging, not to mention the wear that happens on these little bitty plugs that we're using. I know Frank Vella and Mark Smith do not use a switch. It's a source of problems, they think, and they don't use a switch. But I have a switch in all my boats, and I have no plans to change from that. You just got to maintain it.
So they're just unplugging and plugging.
They're unplugging and plugging the pack each time. I leave my battery packs in the boat. I very rarely will ever take them out. Another disadvantage, by the way, of a LiPo is you have to take it out because you do not want to charge it in your boat. If it overheats quickly, it'll just, it's done. Melt your boat. So I have 2 of these. One I'm in the basement hooked up to a power supply. One of them I keep in the car hooked up to the lighter outlet. You can also get a more sophisticated type of charger which discharges. And as you get more into the hobby, it may be worthwhile investing in that. So, for example, let's say that it's a person who has an inexpensive charger, maybe even a wall charger, and they say, man, this is a great hobby, I'm going to do this. At that point, it might make some sense to go buy the AccuCycle Elite, which is $100.50 or so, because that does everything. Discharges, recharges, memory, and the whole 9 yards. Before the break, Wayne brought up a point about as far as the battery chargers, there's literally hundreds and hundreds of choices. I would recommend that if you absolutely know nothing, I would recommend you go to your local hobby shop with a couple of caveats, a couple of unless. I would go to the hobby shop, and you have to realize and make the hobby shop person understand that you're not racing electric cars and you're not flying planes, because they will oversell you, because that's what they're used to. They're used to somebody who wants a battery pack that's going to run for 4 minutes and charge in 15. And they will oversell you in terms of the battery charger, the packs, and everything else. And you'll get more than you need. You'll be paying too much because you're never going to need that with these boats. These boats are not they don't have a high draw as long as everything's working right. And they're not hard to put the right pack in. Getting back to the batteries for a minute, when you buy a pack, you can buy them ready-made, or you can have them made for you, custom made. And I go to an outfit called Cheap Battery Packs, and they've always been great. I did not talk about sizes of batteries. Rechargeable batteries in a AA size are a 1.2 volt battery. I said earlier the Duracells are a 1.5. That is true. But when you go to a rechargeable, you drop to a 1.2 volt per. So to get a 6 volt battery pack in a rechargeable, you have to go to 5 AA cells. The other cells that are available, the most popular one is called a 2/3 A, a 2/3A. And that cell is the one that I actually use more often than not. It is shorter and fatter. And I use that because it can be put into a stick pack. And a stick pack is where you have all 5 batteries in a stick, side by side by side, versus a hump pack where you have either 1 or 2 of them up on top. That's called a hump pack. That's shorter, more compact, but obviously it's going to be tall in your boat, taller in your boat. Either one's fine. I use stick packs when I have a choice, but I also have a lot of hump packs. So when you go into a place like Cheap Battery Packs, or if you were to go to a place like Batteries Plus, a retailer, they could make you packs also. And what you would spec is you spec what cell you want, the brand of cell and type. I use a cell brand called Elite, and I specify those through Cheap Battery Packs as a stick pack, 2/3 A Elite, and online you actually click on the configuration you want, and it comes to you, and then you need what's called a universal connector. That's what these plugs are that we use, a universal connector. There are other variations. I'm not going to talk about those because I don't use them. Therefore, I really would probably say something wrong. But the hobby shop can give you things called Dean's connectors or other types of connectors that are used in other parts of other hobbies, such as airplanes or cars. These are the ones that the radios come with, typically when you get a receiver. This is the kind of plug that they're looking for. If it's a Futaba, it will have a little key on one side. So if you get a Futaba radio system, Futaba receiver, it's going to use a Futaba plug, but the universal will also work in that. So when I order a pack, the Elite packs the Elite battery cells are very, very good cells. They may not be the world's greatest, but they're certainly better than the run-of-the-mill cells you get if you buy a standard pack in a hobby shop. My results with those packs are, when I get a new one, I run it through 2 or 3 cycles. It comes to you with a charge. When you get it, it will have a charge, but not a full charge. So what I do is I charge it all the way up at a very, very low rate, usually a 0.2 amp or 200 milliamp rate. I will take it up all the way to a full charge on one of my chargers. Then I will discharge it down to 1 volt on my discharge charger. Sometimes I use the same one, obviously, for that. Back up, and I will do that about 3 times. The last time, the charger that I have records how many milliamps it put in. And I have had those. I buy a 1500 milliamp pack. I discharge it to a 1 volt, so it's not a complete discharge. And believe it or not, I usually get just short of 1400 milliamp capacity out of those packs. So that's a good pack in my mind. There's efficiency you lose. The cell is by itself, but when you start soldering them and welding them together in a stick, and you start putting wire on them and plugs on them and all that stuff, everything they do lessens the amount of performance you're going to get out of that cell. There's no way to avoid that. So I'm very, very pleased with those. I've had 1 or 2 bad ones out of the 15 or so that I've purchased probably. They were never a problem. They deliver lightning quick. I'm talking 4 days. And it costs like $4 to ship them. And of course there's no tax. So there's an advantage there. And I've turned John Richmond and some of our other people onto those, and they've also had similar experiences where they work really, really well. And that's actually in this write-up that you can download. So this brings us to conditioning and taking care of your batteries. When you get a new battery pack, It will have a charge, but the last thing you want to do is put it in the boat and go sailing. Because it's a small charge, you have no idea how much it is. You have no idea how much is in there, whether it's going to leave you stuck in the middle of the lake or not. But even more so, you're going to damage the battery if you do that. In order to make the battery last, the pack last the best, what you should do is take it home and you should charge it up on your regular charging system at the lowest possible rate you have, a 0.2, say. That's the lowest rate on this one is a 0.2. You're never going to hurt it on that. You're never going to hurt it on a wall charger either. So you charge it all the way up at a low rate. And the charger will tell you when it's fully charged. The wall charger will not. The wall charger charges at so low a rate, it charges at usually about a 0.15. Is 0.15, not 1.5. So a wall charger will take 20 hours or so to charge a fully discharged pack. 20 hours or more. So what you want to do is take it, charge it up, and then take it all the way down and back up again, low rate, all the way down and back up again at a low rate. All of that's at 0.2 or something like that, really low rate. At that point, the battery's ready to be used. You will find, if you have a device that measures how much it puts in, you will find that the first time around it may only put in 7. I just did some this week. It'll only do 700. So I had a 1600 milliamp pack. The first lap, if you will, the first time, it only put in 700. The second time it put in about 1200. The third time was 1489 out of 1600. That's good. If you can get to 90% of what it's rated and you've only discharged it to 1 volt, that's good performance. So I then put a tape on it, I write the number on it, and that's how much that one holds. So that pack has been conditioned and it's ready to go, and I will put it into my system, whether I put it into a boat or put it into my carrier. That battery pack will lose in a period of probably a month or a month and a half. It will drop down from about 7.4, 7.5 volts. It'll drop down to maybe 6.5, 6.8. Unused, sitting there. That's still good. In other words, 6.8, if I had to put that in, those are the ones I carry around in my box, right? If I had to put that in, I still could sail 3 or 4 hours with no problem. So that's the way to maintain it. That's the way to put a new battery into the system. You need probably 2 batteries. You need one in the boat and you need one in the box, because at a regatta, I always change batteries at noon, at lunchtime.
Are you doing rechargeables in your transmitter?
No, I don't do that.
Okay.
The reason is that it's one more thing I have to remember to charge, and it's also so these radios are so good. All of them, well, there's a couple brands that aren't, but the Spectrums and the major brands, I can go through. I can probably sail for. I'll change one time during a season. So it's 4 Duracells. I usually buy a 20 pack of the best ones I can get. You know, I won't buy an off-brand. I won't buy a Sylvania. I won't buy them at the dollar store. Okay, I will buy a Duracell copper top, or I will buy, now I'm using Quantums, which are the higher capacity ones. But I carry a set of 4 of those in a Ziploc bag in my carrier, and I can pull those out and change them without, I mean, you put the boat in a rotate mode and change them right there on shore. It's just so easy, and you don't have to remember what to recharge. Some people are really, really environmentally conscious and they want only rechargeables, and that's okay. It'll work. But it's just, if you had to put new ones in every week, it'd be a whole different thing. But since you only do it a couple times a year, for me, it's...
Yeah, that's all I've done with mine.
Yeah, I just carry them. We have Rob Hill, very good sailor. He sails with Duracell AA's in the boat. He has a holder.
That's me.
Yeah, and he uses those, and he says he gets great performance out of them, and he doesn't have to worry about the charging. And that's fine. That's good if you like.
Yeah, you get great performance until it starts dropping
losing.
out your
First thing you lose is control, right?
Oh, yeah.
Yeah.
Well, the other day when I had that issue, I was out there with my dry cells and going along just fine, and all of a sudden I'd lose my sheet. I wasn't steering at this point. I was going, whatever heading I was on, and then it would come back in. fall off and come back in and fall off, and then I started having no steerage.
Yeah, well, that's good, because I'm glad you brought it up.
And those batteries, by the way, I took out and I took them home and I put them back in my battery pack and I measured my battery pack. And those batteries were at 4.9 volts. I had no control.
Yeah.
Fresh batteries, I was at 6.1.
Yeah.
What it came out to.
But you had 4,
Mm-hmm.
so that's 4 times 1.5.
Right.
That's a 6 volt nominal
Right.
output. And you got down to 4.8,
And I started losing control.
well, the first thing that happens when the batteries get weak, the first thing that happens is you'll get some chatter. The next thing that happens is that your sail servo that's the one with the highest load, that takes the most juice. The sail servo will start to not work.
Mm-hmm.
And thankfully the rudder is the last thing to go, because that's kind of what you really need that to get back.
Sure.
You wouldn't want the rudder to fail first. And it's good that way, because it goes by which one draws the most
Sure.
power. Obviously your sail servo is going to draw the most, and the rudder servo least, or other than, of course, the receiver will actually draw the least. But nothing works right if you're not getting at least a nominal amount of voltage through the system. So we've conditioned our new battery, and everything's fine, and we put it in the boat. But the problem with these boats is corrosion, and we have to address that. New people, I've had, and people who aren't so new in our club, have had issues where you take their boat home, and I won't mention Al's name, but I took his boat home, and it was like a corrosion factory inside. Every connection was green, because those are copper connectors. Copper turns green when it starts to corrode. Every connector in Al's boat, I'm not going to mention whose it was, but every connector in Al's boats was green. From the battery to the switch to the receiver connections were green. And he was having a lot of radio problems. Well, it turns out I cleaned all that up and put it all back together again, still having radio problems, and it turned out that it was his radio, his transmitter, which he sent back, and this is a little plug for Spectrum. He'd owned it for 4 years, maybe 5, maybe 6 years, long time, a DX5. He sent it back to them, he borrowed one from me, and within about 10 days he got a brand new radio back. And that's been my experience with them too. They're terrific. I actually screwed one up I was working on it, shouldn't have done that, but I'm working on it. I actually had pulled the connector off the circuit board for the antenna. Just pulled it out. So I sent it back to them with a little apology letter saying, is it practical to fix this? I mean, you're talking about a $50 radio that cost about $8 to ship each way, right? Mm-hmm. And they sent it back to me, brand new radio. And this was after 3-4 years. They sent me a brand new radio back with a note saying, we have you on record now. Don't ever do that again.
So I had a 4-day turnaround on a 6i.
Yeah, but that was a newer one.
Yeah, but
No.
on warranty, 4-day turnaround.
Yeah, and it depends on their workload. They're just phenomenal. And for that reason, I will never buy anything but a Spectrum radio because of that. And I will never recommend it. 'Cause there are lots of good radios. Futaba is a very, very good radio, but it's generally a higher price. And I don't think you could beat the service that you get out of the Spectrum people. I've sent receivers back. I just got a servo back that smoked, and I sent it back. It's the one that quit at Burrow Pond. My servo just died. And I sent it back to them, and it was an expensive servo. It was a $100+ digital. They rebuilt it and sent it back to me. So they've...
They give any explanation?
That's actually high tech. High tech has been very much the same. Yeah, they said the circuit board was shot. The CB, in effect, was shot. Okay, back to batteries. So, you've got your new battery pack. We've conditioned it. We're using it. You also have to, before you put that new pack in, I always like to go through the boat and clean everything. And the way I do that is I use a nylon brush on a Dremel. Don't use metal brush. Not good, because there will be sparks and stuff. But I use a nylon brush on a Dremel, and I just go through and clean all the posts. It will reach down into the holes of the female connector, and do the best I can. You can also dip them in an acid material. That will clean it off, and the one that you could use would be a bowl cleaner, bathroom and bowl cleaner. If you look at one, it'll say hydrochloric acid. You know, really small percentage, but you would dilute that with some water and dunk it in there and let it stay wet for a little while, then rinse it off with water and then dry it with a hairdryer.
Yeah, Tarnax works wonderful.
Yes, Tarnax is another product for silver cleaning. That's an acid.
Right.
Works the same way. I've never actually had to do that. The wire brush or the nylon brush has always done fine for me.
Okay, I use a Deox, not solution, but it's a paste.
You know,
In my
there's lots of
connections.
chemical ways to do this, but I try to stay away from the chemicals and keep a dry boat. That's the
Well, I have a
approach
dry
use.
boat. I haven't had any issues with that, but I still do that on
It's
any
still a
electrical
wet boat if you
connections.
don't treat it right, though, just because it's on water. The other thing that works is a toothbrush. A stiff toothbrush works great, and just when you return it to the bathroom, don't tell your wife that you used it. It'll work fine. That's a joke. Anyway.
Well, I was gonna say, have you done that?
Yeah, that's a joke. But if you keep a dry boat, and if you do some good practices in between sailing and some good practices over the winter, you won't have any problems. So what I do, we get to the cleaning. There's another product called Corrosion X, which Mark Smith absolutely raves about. It was developed for the aircraft industry, the real aircraft, full size. Navy aircraft, and it works great, and you can actually spray your connections and put them underwater.
Well, that's what my Deox does.
Yeah,
I use that on rooftops and disconnects and stuff like
but
that.
I'm not so sure that I would do that. You know, put them underwater, even though it's really a cool demonstration. But I'm not sure that I would do that. I don't use Corrosion X. It's very expensive. You have to order it online, and I just don't have any problems by keeping everything dry. Al's problem, that guy that I didn't mention his name's problem, was that he stored the boat in the garage under a canvas tarp
With
over
the
the
hatch
winter.
closed.
Yeah. No, a hatch was open, but it was under a canvas tarp, he tells me. So the change of temperature creates condensation inside the boat, and that's why everything got corroded. So you don't want to do that. You want to store it. I store it in the basement, usually, during the winter. It's in the basement. I do a full cycle discharge, recharge on all packs, and I put new numbers on them. So if you ever get a pack from me, it'll have a number on it, and that'll tell you what it holds. And I find that they're pretty much exactly to where they started. Then what'll happen is one time, what the number said 1375 on a 1500 milliamp hour pack said 1375, and one winter I'll do it down and it'll do 700. So I'll do it again, it'll say 700 again. That tells me that pack is like almost done. So that one comes out of the rotation, and that becomes a bench pack. That's one that I use for testing. I use for when I want to bind radios, you know, that kind of a thing. And then eventually I dispose of it, because you cannot take a chance. To me, the sailing is worth too much. I mean, we do this, we do it a lot more days now, but there was a time we only did this for, 13 days a year. When I was early on in the club, we only had 13 Saturdays a year. And I'm not going to give up one of those Saturdays over a battery pack. It's just not worth it. There are guys that could care less. They want to do it cheap, they want to do it easy. I'm just not one of those guys. I like to do it the right way, because it's just too important to me to miss that. Of course, now I'm doing it pretty much year round when I go to Naples. So I'll recharge those things and then take them with me when I go in December. So, back to packs. The packs you buy at the hobby shop work fine too. Keep in mind that you're going to use maybe 300 or 400 or 500 racing milliamp hours. That's what you're going to use. So if you have a double that, or 1100, 1200, 1500 pack, that's plenty, assuming all the connections are good. If the connections are bad, you can't put a big enough pack in there, because voltage is what overcomes corrosion. You'd have to have higher voltage to be able to jump across that green crud in order to make the boat do what it's supposed to do. So So at the end of the sailing season, check all your connections, clean them, store the boat with the hatch off, store it in the basement, store it in a corner of the house. Probably the garage is a bad place to store it because of the temperature change. You're going to get condensation. The other thing that I have a hard time with, I had trouble with my own son on this one. When the boat leaks, when something starts, fix it. You know, people all the time, the boat, oh, it got a little water in it. Well, the water came from somewhere, and you need to figure out where it came from. It may be that it's a simple, real windy day and it came through the hatch, and you dry it up and you don't worry about it. You also want to put the boat together so the electronics are not on the floor. I have only in one boat ever put the battery or anything on the floor, and that's because there was just no other place in a Micro Magic to put it. So it's on the floor, you know, behind all the rest of it, which is off the floor. But you have to, Doug, my son, had a boat that had 3 inches of water in it, and he left it that way for 60 days. And surprise, the wood was all rotting, the electronics were shot, and it all had to be basically the guts of the boat thrown away and rebuilt. He took it home, left it with the hatch on, put it in the basement, and didn't sail for a couple months. And next time he took it out, surprise, it wouldn't work. And that's just, you know, you just don't do that stuff. When it starts leaking, figure out what the problem is. You can fix it with thick CA, you can fix almost anything, a crack or whatever. Usually the cracks will be around the combing, the hatch combing, or at the flange around the boat. Take it outside, flip it over in the sunlight, use a light, and find the leak and fix it. I know it takes a little while to do it, but it's certainly not good for your electronics to have water of any kind in the boat. And build a dry boat in the first place. It's important to do that. I think our boats, when we build them, are typically dry. We're not having a whole lot of problems with that, except Thad when he sank.
I mean,
He had a
as
wet
much
boat.
abuse as my boat has had over the years, it's still nice and dry.
Yeah.
Except for on those heavy wind days, I got some water in there. Not
Yeah,
much.
that one, what I'm doing now is I got some high-tech closed cell insulation material at the hardware store, 3M I think it was, and I actually put a strip of that around the underside of the hatch and then the rubber band holding the hatch down, and I'm completely dry. No matter how wet it gets, I just don't get any water. And that's a good solution. That's one Frankie taught me. I'm not a big fan of the latch, you know, with the turning piece of wood thing. I use a pretty simple rubber band thing that holds the hatch on. I like simplicity, and I like straightforwardness, and I don't like complication, because complication leads to trouble in my mind. Okay, so at the end of the season, you want to clean all connections, you want to charge, then discharge all your packs, recharge them fully, so they'll be up to full charge, and then probably in January, go down and just top them off. And then probably in March, top them off again before you start sailing, and then they're in the cycle and you're using them, and everything should be great for another sailing
You
season.
know, and that's nickel metal hydride, not lipo or life.
Right.
And you're
Yeah.
talking about topping them off, or you're talking about discharging
No,
them more?
no, you don't have to.
Oh, okay.
They'll drop down into the 6-volt range somewhere, and you put them on, and they stay on for 15 or 20 minutes, and they're back up again.
Okay.
You don't want to let them discharge all the way down by just age. Ways to discharge packs. You can use one of these devices. A battery charger is a very sophisticated way to measure things. You can also hook up a light bulb to a wire, 2 wires, light bulb to a universal connector. Go get an extension at the hobby shop and cut off the one end and just hook it up, solder it to a 1157. So an 1156 bulb is the one that has one filament. That's an old auto bulb. You solder the black wire to the collar and the red wire to the tip, and it will draw down at about 1/4 of an amp per hour.
It also makes a great way to dry the inside of the boat.
Yes. Just don't let it
Just
get
don't
too
let
hot.
it rest on the boat.
Yeah, don't get it too hot, because styrene is about 130 degrees or so. It starts to melt or get soft. So, if you're a newer person, I would try to keep it simple, and I would go out and buy a rather inexpensive charger like this, and then use it. If you're like me and you know that you're going whole hog into every time I've done a hobby, I go off the deep end on the thing, I would go ahead and spend the money on a good charger. It's worth it. And you'll know after you sail for a while. You enjoy it so much, then it's time to go invest in the best stuff. So, any questions, comments? That's it? Okay, this is on our website, and it is kept up to date, even though the one that's on there right today is a little bit out of date because it doesn't have the life batteries on there, but it will as soon as I finish